don't need it, right? So, okay. Um, all right, looks like we're going live. So the new concept that we have not talked about yet, and that is the subject of the last part of tomorrow's lecture, is going to be electric potential. So I need to talk about it a little bit today. So let me see if I got this here. And I think you'll like it a lot more than electric fields and Gauss's law, because the equation for it, for a point charge, is the capital letter V is going to be K Q over R. So let's say you have a plus charge right here, and you're some distance away at the point P. So again, this would be our point of interest. This is the source of the electric potential. So if we go out here this way, that would be R. So notice it's a scalar. Now, it's not a magnitude. A magnitude is always positive. A scalar could be positive or negative, just like you could have positive or negative temperature if you're using the Celsius scale. That's a scalar. You could have positive or negative energy. If you're talking about potential energy, for example, in orbits, you get negative potential energy usually. And so in this case, we see that this is a scalar, and this has units of, any guesses what the units are? Look at the letter.
Volts.
Volts. This is going to be voltage. So finally, it's one more level of abstraction. But what's going to happen is after we get through the next chapter, we could talk about voltage. So we can start talking about batteries and capacitors and things that you actually do with your hands instead of all this crazy math. So right now, you guys are in probably the 4 hardest chapters you're going to get, arguably in all of physics here, at least for undergrad level. And certainly this is one of the harder courses you're going to encounter as an engineer. So of course you're all hurting badly right now. But remember, after this next chapter, it will suddenly change to something that's easier to kind of conceptualize instead of just pure math all the time. So if you're just frustrated and losing points and struggling, remember there will come a time when it's a little bit easier. Let me get Victor in here. All right. So and for now, maybe you're wondering what this relates to. It relates to electric potential energy. They're not exactly the same thing, but they're related. And so in our lecture tomorrow, I'll discuss how this relates to electric potential energy. But for now, just know that when you're doing the coding assignment today, we're going to use this to figure out the electric potential from a point charge. And notice it's going to be a scalar. It could be positive 10, negative 12.3, some number. If you plug in K, Q, and R, it's just going to be a number, either positive or negative. And that's all the theory we need. And do know that this relates to, and the units will be in volts, and that this will relate to energy. And so instead of doing problems with forces and vectors, we're going to do problems with energy in the next chapter, which usually students like because it's a scalar. All right. Okay. So let me pause on that. Any questions about that? Should be pretty.
Would you say moving on, conceptualizing isn't the only thing that gets easier? What would you say about the math? Does that get
the math gets much easier? Yeah,
simpler?
It's algebra instead of calculus.
Oh, thank God.
So yeah, and you aren't going to have 3 forms of density for one question. So yeah, I mean the math will get easier too. That doesn't mean you can not practice, but you definitely it'll be easier to practice and less frustrating and quicker to get results.
No more using 8 different R's, right?
Probably not until we get to a later chapter. Yeah. No, but you'll see. I've set this up so that there's another hard chapter later where we talk about Ampere's law, which is the current version of Gauss's law. Gauss's law uses charges. Ampere's law uses current. But because we've kind of laid the groundwork, that chapter will be much easier. And the Biot-Savart law will be usually a very complicated law, will be very similar to the way we've done it. So I don't do this exactly the same way as every textbook, but I'm doing it to make it more similar to the harder chapters later. And so basically it's putting all the work in these first 4 chapters, and then we apply it in different ways going on. And I think what you'll find is it's easier to pick up those later chapters. I don't know. Did that make any sense, Rye?
Yeah, totally. That
Okay.
makes sense. Yeah.
Yeah. So you're doing, this is the worst chapter. Get through this one. And even the next chapter is easier, right? Scalar is easier than vectors. So, all right. So tough it out, get through Gauss's law. Um, yeah. What was I going to say here? I don't remember. Oh, let's take a look at the kind of the idea for today. Okay. Oh, come on. And so you could see that what we're going to try and do is, let's see, the code. Okay, so what you're going to try and do is make an array of field arrows. And then here's some tips for that. And here's some tips for how different ways to use your for loops. And this is kind of a review of last time, is showing different ways to make arrays. You could use for loops or you could use while loops. And if you haven't noticed already, those for loops sure look a lot cleaner when you write them. But whatever. So there's different ways to do it. And then here is kind of a picture and some scratch work I did. So, some constants. And then what I did here is, you'll notice I left some things blank this time. So hopefully you could figure that out by looking either at your old codes or asking me or thinking about it. And if you're not sure, take your guess, then ask me and I'll help you out. And so you could see that you might need all right, I'll leave it at that. Yeah, there's some sat level comments. So it's putting together some of the previous pieces and seeing if you know how to put them together. And then, so the idea is you could make a 3D code like this. I think what I did right here was I made a 1D code. And I'm hoping that what you could do is use this kind of information that I showed you here to extend the 1D code I pretty much wrote for you into 2D, right? You don't necessarily have to make 3D, but if you could figure out how to make 2D, 3D is pretty easy. And I'll help you if you get stuck. After that, then what we want to do is make a 1D array with electric potential. And so here's some tips. Here's some ways to put it all together. And yeah, all right, let's leave it at that for right now. And I think I'll show you the code. Again, I left some pieces kind of blank here. And so you could see, here's the code output of the 2D. And the idea is, if I could, let me see if I can go to here. Okay. I got you. Let me see here. The big picture of what you're trying to do is, let's see, fet charges and fields. I'm hoping you guys are going to make this simulation. And obviously their simulation's a little bit cooler. They could do the drag and drop. We don't have to do the drag and drop. But the idea here is, if I put out a plus charge and a minus charge, it's going to draw the field arrows. Furthermore, I can display the voltage, and that's what these the red and blue things that I was trying to get you to look at. And maybe let's make it a little bit more blue and a little bit more red. So the idea is, I'm hoping you make something that looks like this, where you can tell the computer where to put the plus charges and the minus charges. And maybe you could even spread them out a little so it looks cooler. And then the idea is the computer will determine the red and blue shading and draw the arrows for the electric field. That's your goal today. Not figuring out how to do this crazy mouse crap. That's too much for me right now. I just want you to basically hard code the position of 2-point charges and get this simple version right here, right? If you could just handle 2 charges, get the arrows and the colors, you're golden. All right. Let me see here. That's your big picture goal. Let's see if there's any questions right now. Obviously you could be figuring out, yeah, and Nate Dog, we could look at yours in just a second here. You and Josh made a code already, and we'll take a look at that in just a second. Double click play. Okay, I got you. Yeah. Other questions. So again, the ARC code is due tonight. The code that I'm talking about today is due next week. All right. And so I think it's best that we maybe just open it up and let you start working. And if you have any questions or if you're completely lost, I can go over it more slowly or something. But I think I should stop the screen share at this point. So let me do, or the live stream. What was that? Whoops.